So today we are going to discuss the design of an electric car with manual navigation and pass with modulation speed control. Before we go through the design, okay, you need to understand the mechanism behind the car operation, how the car works. Okay, so it is very important to understand the mechanism behind the car operation. So let's see what is the mechanism behind the car operation. Most of probably many one of you are very familiar with the working mechanism of the car, and probably you know how to drive the car, and you have seen the inside of the car, right? So let's see what is the best way the car works. Let's do a very simple picture. Let's see, this is the shaft that connects to wheel. Okay, let's say left wheel. This is the left wheel, and this is the right wheel. And in conventional car, there is a engine. Okay, car engine, combustion engine. Okay, so let's say this is the car engine. So this engine burns oil or fuel, oil or gas, and produce heat energy. That heat energy get converted to rotational energy, okay, through gears, through some mechanism, okay. So that rotational energy rotates the wheel. So this car get connected. So this drag these two wheel, okay, left wheel and right wheel through this shaft. So this is the way the conventional car system works. The engine generates the energy. That energy get converted to rotational energy through gears and other mechanism, okay, and that rotates the wheel. And what else? What there? Consider the steering mechanism. It is a manual steering mechanism. Sometimes can be motor assisted. You can call power steering, okay. So steering mechanism. Steering. That means you move the wheel left or right or keep it straight, okay, to control the car direction. So this is the very basic working principle behind the conventional car. It has the engine, that combustion engine that convert heat energy to rotational energy. So you can that wheel can move to the shaft, okay, it's common shaft, and through the steering mechanism you move the car left direction, right direction, okay, forward, and there is a gearbox. This gearbox, okay, so this is the gearbox. Through gearbox, what you do, you vary the speed, you vary the direction, forward direction, reverse direction, okay, and you vary the speed, slow speed, medium speed, high speed, parking, okay. So the gearbox, you control the speed and direction of the car movement. So this is the gearbox that you operate manually, right? Also the steering and the engine gives the driving force. So this is the way a conventional car works. Now, in case of electrical car, okay, when you want to design an electrical car, we don't need this gearbox. Okay, in electrical car, we don't need the gearbox. So we can delete the gearbox, and we don't use the conventional combustion engine that convert heat energy to rotation energy. We use electric motor. Okay, we use electric motor. So what happens? Let's say we want to design the electrical car, and let's say we'll connect the motor, one motor, left motor. Our plan is to use two motor, one for the left wheel, okay, one motor for the left wheel. It can be a DC motor, electric motor, okay, that will be connected through gear mechanism, the left wheel, and another motor can be connected to the right wheel. Okay, another motor through gear mechanism, they will drive the right wheel. So two motors, one for left, another for right. Why two motors? We can also use one motor. Okay, one motor will have less power, two motor will give more power. And for conventional operation, what we'll do, we'll connect these two shafts together as the conventional car system. So we'll have a connection mechanism that will connect these two shafts together to make the connection for normal operation. Okay, for manual navigation, this will be connected together, and they will be connected together, and so both motor will supply the driving force and will have more power, okay, instead of one motor. And it has another significance. Okay, this design we want to use for future development, for automation. Once we want to go for automation, that is first you have designed your basic electrical car, and then you want to go for automation. Once you want to go for automation, then you need to manipulate this left wheel and right wheel separately. Otherwise, define complex steps you cannot make. Suppose in future you want to design the transformer robot. Have you seen the movie Transformer? I think most of you have seen the movie Transformer. Okay, it is a robot. It is a car. It becomes a robot. Okay, from robot it becomes the car. From car it becomes the robot. So if those type of advanced device, if you want to design, then we must control different wheels separately, different motors separately. Okay, so this simple design, if you want to proceed further, if you want to go for automation, in that case, it is very important to control different motor, left motor and left wheel and right wheel separately. Also, if back wheel, also you can connect manipulate separately by using different motor. Okay, so it is very important to have individual control of individual wheel. If you want to have complex step, complex movement, let's say auto parking, if you want to do right turn, that means if you want to design the working of the car system, you need to understand, okay, how to do the right turn. Okay, right turn can be sharp right turn, normal right turn, wide angle right turn, depending on the scenario. Okay, when you want to design the advanced system, we can use the visual image recognition system and understand the image situation. Okay, road status situation. You need to do, let's say, sharp turn. Sometimes you need to do wide angle turn. Sometimes you need to do let's say normal turn. Okay, so different types of manipulation or operation you need to do depending on the situation. For those complex operation, it is very important to have individual manipulation of different wheel. So for a complex operation, we need to manipulate different wheel separately through different motor. Okay, and for basic operation, we will combine these two different shafts together, and it will act as a single shaft, and like the conventional motor mechanism. Okay, so first in our design, we will assume that they're connected together. Okay, it's single shaft because we are designing a basic motor electrical car system. Okay, but make sure once you understand the basic design, and if you want to advance your design, and if you want to go for automation, then you should have the mechanism to separate this shaft, separate these two different wheel and two different shaft. Okay, and should have individual control over different wheel through different motor. That's is required for the automation. Okay, otherwise many complex steps we cannot make. Okay, if they are just together. Okay, so for common operation, these two shafts will work as a single shaft. And certainly the steering mechanism. Okay, this steering mechanism same as the conventional motor system, unless you do the automation. Okay, once you go for the automation, maybe this steering mechanism can be completely omitted. If you do the advanced type of automation, then your program will do the steering itself. Okay, by manipulating the car operation, the wheel operation, manipulating different motor, the computer will do auto steering for you. But unless it is safe to have a manual override steering, okay, of your car system in case of emergency, so that you can manually override the automation and can save the accident. So this steering mechanism is will remain over there as a conventional, uh, and as you know, it is a very simple system. Sometimes we call power steering. It can be motor assisted, and you just move both wheel in the left direction or right direction, or keep it straight. Okay, that's simple steering mechanism used in the car. Okay, but for again for advanced automation, once you go, the steering will be controlled by your program automatically. Okay, so keep in mind when we discuss the design, we are using a basic car system. That means both wheel on the same shaft, conventional steering, and two motor we are using to give more power. That means then our motor will get more power. Also, I think it will also increase the reliability of the system. For example, in case one motor fail, another motor can take over. Okay, so it will make your system more reliable. Okay, and this motor will be certainly driven by the battery power. So you should have, I think, good battery system. Okay, for your electric car. So two motor will give us more power and more reliable operation. Okay, so that's the basic mechanism behind your car operation. And with this basic understanding, we want to go for the design of the electric circuitry that will make your electric car move. Okay, so let's go for the design. And for our design and simulation, certainly we are going to use a very famous software called Proteus from Lab Center Electronics. And most of you are familiar with the software. We have used this software for different project, different labs. So let me just remove this design and start Proteus. So we need to run Proteus. This is the Proteus icon on desktop. Right click the icon and click Run as Administrator. So it will open up the Proteus software, or we can design our circuit and simulate. So what we are going to do, We are creating a new project. Click the new project from the start menu. So when you click the new project, it will open the new project wizard. So give a name of your project. It's a car key. So when you insert the key, it will start the car. And this is the location where you are going to save the project. By clicking the browse option, you can change the location. Okay, so just give a name. Click the next button. Click the next button. Click the next button and click next. So it will open up the schematic design window. Now, what is the purpose of car key in our design? The car key will start the car. That means it will supply the power to the Arduino board. For our design, we are going to use the Arduino Mega. Okay, so this is the Arduino Mega board. Look at over here. This is the microcontroller board that we are going to use for our design. So the key, when you insert the key in the car, it will give power to this Arduino Mega board, so that the system will come alive. So how many ways you can give the power to the board? There are several ways you can give the power to the board. Okay, this is the V in pin on the board. By this V in pin, you can supply the power. Now, from the USB port, by using a USB cable from the power bank or battery, you can give the power to the board. Or from this power jack. Okay, this is the power regulator. How much power you need to supply to the Arduino Mega board? Okay, how much power you can use in the board? Okay, because look at over here, this power regulator. Whatever power you supply, okay, this will regulate and actually it will convert to stable 5 volt. Okay, so you can give more than 5 volt. So let's browse the net and find out how much power Arduino Mega board support. It works usually on 5 volt, okay, but you can give more than 5 volt to the board, but it will convert that extra that means more power to 5 volt, okay, internally by the power regulator. So let's see power requirement by the Arduino Mega board. Give a search on Google. Power of Arduino Mega 2560. Okay. It uses only 0.27 watt. Okay, measured at the USB plug using okay 52.5 from milliampere current. It's drawing. Let's see how much power does an Arduino Mega use. Okay, with a 9 volt power supply, the Arduino Mega has a power consumption of 73.19 milliampere. If you reduce the clock speed, the power consumption decreases to 61.76 milliampere. And if you also reduce the power supply from 9 volt to 3.3 volt, you can achieve a current drop of 16.74 milliampere. Okay. How do I power Arduino Mega? The Mega 2560 can be powered via the USB connection or with an external power supply. The power source is selected automatically. Okay. External non-USB power can come either from AC to DC adapter or battery. The adapter can be connected by plugging a 2.1 millimeter center positive plug into the board's power jack. Okay. So how many ampere can Arduino Mega handle? At Mega 2560 can handle, okay, limit of 40 milliampere on each pin and 200 milliampere in total for all pins. Okay. So what we see from here? Okay, operating temperature 50 minus 55 degrees centigrade to plus 125 degrees centigrade. Okay, and voltage on any pin except reset with respect to the ground minus 0.5 volt to plus 0.5 volt. Max, okay. Maximum operating voltage 6 volt. Okay, maximum operating voltage 6 volt. DC current per IO pin is 40 milliampere. DC current VCC and ground pin, that is total is 200 milliampere. Okay, so input voltage recommended 7 to 12 volt you can give, but the limit is 6 to 20 volt maximum limit. Okay, because it is an onboard power regulator. Look at over here. This is the power regulator on board. So you can use let's say 6 to 20 volt. Uh, that's the maximum limit. It has 54 digital I/O pin. Okay, of which 14 provide the PWM output. It has analog input pin 16. DC current for I/O pin is 40 milliampere. DC current for 3.3 volt pin is 50 milliampere. Okay, and this is the flash memory. Okay, 256 kilobyte of which 8 kilobyte used by bootloader. It has static RAM is 8 kilobyte. Okay, so what we see from this data, that it's a very low current device, and for very low current device, we don't need to use any specific or sophisticated system. Okay, look at over here. You can simply just use a manual switch. So go to the component mode and click key and type button. So simply a button is quite enough, okay, for the key. So what we do, by the button, we need to connect the power. So battery, type again key again, type battery. Okay. And we have seen the limit. Let's make connection of the battery. And how much voltage you want to give? 6 to 20 volt. It's a 12 volt battery. Okay, over here. But limit is 6 to 20 volt we can give. So you can take even less than 12 volt, okay, depending on your requirement. So so if you click, so from here you see, this is the basic circuit for the key can be, because this Arduino Mega is a very low current device. Okay, so when you just press the button, you just need to connect. Let's pick up the Arduino Mega board. Arduino Mega. So this is the Arduino Mega board, and through wire, you can connect this the USB input or to the power jack or even to the 5-volt VIN pin. You see, PCC 5-volt VIN pin you can connect. Let me just enlarge it a little bit. Okay. So you can connect this battery to the ground. And this part you can connect over here, or over VCC. Okay. And for the ideal input voltage for VCC, I think you can change it to 5 volt. As we have seen from our data, you see, input voltage 6 to 12. Okay, so 7 to 12 volt recommended, 6 to 20 volt limit. So academically, you can set up your voltage, okay, what voltage you want to supply. So this can be the basic key system because Arduino Mega, this microcontroller board are a very low current device. For very low current device, you don't need to use any relay. But if you want to make your design more sophisticated and there can be different parts on your car that you may need to use the relay to control different part for high current device. There can be other some component on your car system that requires high current. So in those situations, you need to use the relay. And how to use the relay? Let me draw a simple diagram. Okay, but for the main key system, there's no need to use a relay. A simple button will do the job. Okay, a simple button will do the job. When you press enter the key, it will just close the circuit, and Arduino microcontroller board will get the power, and the car electrical system will come alive. Okay, when you remove the key, it will break the circuit, and the car will stop. Okay, so that's the basic key system that you can safely use for the Arduino Mega or microcontroller board because they are very low current device. Okay, but there, as I have told, that there may be some other equipment or some other device that needs high current. So on the situation, you need to use a relay. So let me show you how to use the relay. So let me just delete this part. So how you want to use relay? Then we will pick up. So look at the left side. You need to click the component mode, then click P and type relay. And on the search bar, RELAY. Okay, so animated relay model. Let's pick up this one, basic. Okay, this 12-volt relay is very common. If you see, relay comes in different model in the market. Look at over here. Give a search on Google relay. Okay, relay. Okay, this is a different diagram for the relay. Okay, relay are usually used to operate high current device. Let's say your switch on the low current side, and to the on and off the high current device like a motor circuit. Okay, you need to use a relay because motor draws high current. Okay, so these are the different type of relay. Okay, Look at over here. This is the movable contact. This is the coil terminal, and this is the, I think, operate from here. Okay. So let's see how it works. Let's simulate this relay. So relay comes this is 12 volt 30 ampere relay, 5 volt DC, SPDT, single pole double through power relay. Okay, 5 volt DC. Okay. So if you want to make your design more sophisticated for the car key, then you can use this type of 5 volt relay. Okay. Then I think it becomes more sophisticated design, but it's not actually required. Okay, just simple push button switch you can use, but this will make your design more sophisticated and you can isolate the circuit. So let's say how to use the relay. Okay, so this is the 12 volt relay. You can also use the 5 volt relay depending on your need. Okay, so let's connect the circuit. So if you use that I think 12 volt relay, then on the switch also you need to use the 12 volt. If you use the 5 volt relay, then on the switch you need to use the 5 volt. But that is these two voltages. Otherwise, if you use 5 volt and it is a 12 volt relay, then it will not work. Let me do the simulation and let me show you. Okay. Let me complete the circuit. Let me use I think bar to indicate that there's power. Lamp. So when you give the power, the lamp will be on. Let's say this lamp is the output circuit, and you will drive the lamp through other. This is not the source that you are driving the lamp. Okay, you need to give the source. Which source you are going to use to drive to turn on the microcontroller? This is the source. That means this is another battery. This is the main source or main power to the Arduino board or to the circuit that you will supply from. Okay, so you will connect this power to the output circuit through this relay by using the switch. Okay, so let's connect this battery to our output circuit. Okay, so we apply to the battery to the output circuit. Okay, so look at over here again. This is the relay switch. Okay, we are using a 12 volt relay, and on the switch circuit we are using a 5 volt. And let's say we want to supply power to our microcontroller board. Let's say 12 volt power we can give the Arduino Mega. Okay, 6 to 20 volt we can give. So this is the source that will give the power, not this one. Keep in mind, okay, this is the source that will give the power to the microcontroller board. So when we press the switch, this source will give the power. So we need to operate this relay from the key. Okay, so let's simulate. On the simulation button, if you look at the bottom left corner, the play button, click it. Now look at over here. When we press the simulating, when we press the key, no operation. Why no operation? Because look at over here. This relay is 12 volt relay, and on the switch circuit, we are giving 5 volt. So it will not operate because when you close the switch, it will energize this coil. It will get magnetized and it will attract this switch to connect this power supply to the output circuit. Okay, so we need to give the same. If you use a 12 volt relay, you need to give the 12 volt over here. If you use the 5 volt relay, you need to give the 5 volt over here. Okay, so let's stop the simulation. Let's change the voltage over here, 5 volt. Let's make it a 5 volt relay. Okay, now let's simulate again. Click the play button. Okay, press the key. You see, now relay is working. It is a 5-volt relay. Now the switch circuit we have a 5-volt battery. So relay is working and it has connected this power source. This is our the power source, main power source that we want to use to power on the Arduino Mega board. So it has connected the power source to the output circuit and the light is on. Remove the key, disconnect the power source, light is on. So this is the sophisticated circuit that you can use to on and off your car system. And also this type of relay circuit you can use to drive a high current device to the low current system, low current switch. So that's the use of relay. Plus relay can be used to accelerate the different circuit, okay? Because if you use this type of relay, then your main circuit is isolated from the key circuit, okay? I think they are connected by the relay. So this is a good way to implement electrical circuitry in your system. So this is the circuit that we can use for your key system. Okay, press the key, insert the key, light is on. That means you supply this power supply or you connect the power supply to the Arduino Mega board or Arduino Mega board, and your system will come alive. And you can then manipulate your car system. Remove the key, power is cut off. You see, power is cut off. Power is disconnected, and your system is off. So this is the simple circuitry for the current system that you can use for your design. So once you design the entry point to the car, next step to design the main circuitry, main electrical circuitry for your car system. So today we are going to use the technical flowchart method. It is a drag, drop, and play method. New flowchart, click, and give a name. Okay, car navigation and speed. Car navigation and speed control system. And we are going to pick up Arduino Mega board for our project, Arduino Mega. And this is the compiler visual designer for Arduino here. So click next, click finish. So it will open up the design window and the visual designer flowchart window. This project is a big project, so we need to design lots of components over here, and for that Proteus has a good support. So click the design menu and click the new root sheet. So as many root sheet as you like you can create to expand your design, because there are so many components that it will not fit in one sheet. So you can create as many sheets as you like depending on the design, and you can navigate. Go to the previous root sheet or subsheet from here. So in the first sheet we have the Arduino Mega microcontroller, and on the second new sheet that we have created, go to the next root or subsheet. We'll add different components. Okay. So let's add different components for our design. Go to the visual designer, right click the peripheral, click add peripheral. Okay, right click the peripheral and click the option add peripheral. So first we are going to add a display. Go to the group option and pick up this display. Okay, just for a prototype we are using a OLED display, I2C OLED display. So click OK, and if you look at the design window, that displays over here. Again, go to the visual designer, right click the peripheral, add peripheral. This time we are going to add the motor driver circuit. So click motor control option, and we are going to choose this one. Okay, very common that we have used before in different design, Arduino motor shield with DC motor. It has two DC motor. Okay, so click up this one, and if you look at the design window, the motor shield has been placed on here. Motor 1 and motor 2, and this is the control pin for the different motor. Now we are going to use different button, okay, for different operation. So how to use the button? Go to the file menu in the design window and click import project clip. Okay, so let's add button. To add the button, we will go to the design window, click the file menu, import project clip, and click the folder called Arduino, and choose the option Arduino button breakout board. Okay, so this is the first button we have picked up from the import project clip option, and we will give a name to the button. Let's say forward. So when we click the button forward, the car will move forward direction. Look at the pin connection. This button has been connected to input-output pin, IO pin number 2 of the Arduino Mega board. So click another button, pick up another button, input project clip from the file menu, click the folder Arduino button breakout board. Okay. First, look at the option. At what pin it get connected? Okay, they're the same pin number. It cannot. They cannot operate properly. So you need to change the pin connection. So can you pick up IO pin number 3? Look at over here. If you look at over here, let me just enlarge it. You cannot pick up IO pin number 3 because IO pin number 3 has been used by the motor driver circuit. So what we are going to do, if you come over here, you are going to take a different pin that has not been used by other device in our design. Okay, so we'll pick up IO pin number, unlock it, and pick up IO pin number 4 that has not been used. So then lock it again, click OK, and give a name to the button. Let's say this is the break button. So it will break the car. Pick up another button. Go to the Arduino folder, Arduino button breakout board. Change the pin connection of the button, unlock it, IO pin number 5, lock it, click OK, and change the name of the button. Okay. Let's reverse. We don't need the gearbox in our electrical car. We control the motor direction and rotation through the motor. Okay, electrically. Okay, so the motor driver chip, we can change the direction and speed, also the speed. Okay, of the motor. So lock it. Okay. So this is reverse. Button. Then you can use the button. Let's say right movement. Actually, for manual car operation, right movement usually slow down the car so that you can manually navigate the car in the right direction. Okay, so there's another button for the right movement operation. Input project clip from the Arduino folder, button breakout board. So change the pin connection, pin number 6. No, change the name of the button, let's say right. Right for right move. If you press the button, it will prepare the car for right shift, right or right movement. Mainly, it will slow down the car so that you can smoothly make your right movement. Okay, so the steering. So we have used 4 buttons over here: forward, brake, reverse, and forward. Now is the time I think we can go for design, writing the or designing the flowchart. Okay, so it is drag drop and play method. So we are not going to write any code for it, but we are going to use the flowchart technique. Okay, drag drop and play. So this is the setup. Let me enlarge it. And this is the loop part. Two main part of flowchart design or code design. One is the setup part and one is the loop part. The setup part, you need to write the code or write the parameter that run only one time. Okay, once you power on the board, microcontroller board, the code that is inside the setup part will run only one time, and it will prepare the environment for the car movement. So first thing, for safety, the setup part we will stop. We'll make sure both motors are stopped. Okay, so we'll click the motor. You see over here, there is an arrow on the left side of the M1. This is motor 1. So click that arrow. You get a submenu and pick up the stop function. Drag and drop. So make sure it will make sure that motor 1 has been stopped. Okay, not in any other situation. Just for safety. Okay. Again, for the second motor, drag and drop the option menu. So make sure for safety, both motors are stopped. Okay. Now, it is very important. It is very important to have a state variable for every event that you do in your car operation. A state variable keeps track of different state of the car operation. And using the state variable, we know at what state the car is so that we can take proper decision for our next movement. So it is very important to have the state variable for every operation that you do in the car, for every movement that every operation you perform in the car. Okay. So we'll define some state variable. To define the state variable, pick up the option assignment block. This is the assignment block. So let's say this is the window. Double click the assignment block. This is the window. Click the option variable, new variable. First state variable we are going to define, let's say forward move state. Forward underscore these state variables are very important for your program, okay, for your design, because by checking the state variable, you know at what state the car is. So it is an integer value. It can be only 1, or it can be also Boolean, okay, true and false. Let's say integer value, okay, it can be 1 or 0. So let's assign a value forward move state, a value initially 0. That means car is not moving forward. Okay, just defining an initial value. Define another variable, reverse move state. Okay, you can make the variable is the boolean 1 or 0, true false, or integer if you do, then 1 or 0, same thing that you are doing over here. So reverse move state is 0. Let's another variable define brake. Okay, what is the brake status? Initially break variable. Let's see, it is initial also 0. Let's assign an initial value break. We do not use the break because there is an initial condition. So another term we can define is a power on. That means power on variable is, suppose you want to expand your system, more complex system. You have a backup system, let's say microcontroller that can back up your system when the main microcontroller fails. Okay, and you have a storage mechanism so that this state of the first microcontroller can be transferred to the second backup microcontroller in case of failure. Okay, in case of crash. Okay, so it is very important to keep track of all the parameters. Power on. So power on is certainly 1 because you have put the key on the car and you have power on the microcontroller. So at the initial set of certainly it will be 1 because your microcontroller certainly have the power. Let's define another variable is the rotation speed. Okay. Rotation speed in your microcontroller system, it varies from 0 to 255. Okay. Whatever speed you get, it get a map in the range of 0 to 255. Okay. So that's the rotation speed. It should be integer, and the range is 0 to 255. So initially the rotation speed is 0. Okay, and let's say another variable is the speed. Okay, this speed variable another value that can be controlled to the PWM. Okay, so if when we implement a circuit of bounce with modulation of speed control, that circuit will set up this value of speed. Okay, so this value of speed will be set up by the PWM circuit that you set up by using your let's say accelerator, okay, of the car. Okay, if you press the accelerator of the car, it will have higher value in the range in between 0 to 255. Okay, and if you release the accelerator of the car, it will drop the value towards 0. So this circuit you have designed in lab number 6, PWM speed control. Okay, so that circuit of the lab number 6 will be used to set the value of this speed variable. This integer value. Okay, let's set initial speed. Let's say that we have set, let's say 200 or 250 for the maximum speed. Okay, just keep for testing. Okay, the speed that you have set, that means the maximum speed. Okay, 255. We have given initial value. Let's get another variable, right move. That means because we have the button for right movement. Okay, so new variable, right move. How many button you have depending on the state you want to define in your let's say system. For every event, every situation must have a state variable. Okay, so if you want to move right direction, it have a variable. Let's say right move variable. Right move. So when you want to make right movement, this variable will be set to high. Otherwise, this right variable initially is 0. Okay. So how many states? If there are 50 different states in your control mechanism, there will be 50 variable, state variable. Okay. These state variable are very important. Through the state variable, you can make decision, and you know at what state your car is. Okay. Now we'll display some messages on our display. So click a variable. It's a message variable. and this message variable will be the string. So let's initialize the first message variable. Let's say power on, because with a double quotation mark, you need to write, okay, whatever message you want to display. Let's say power on. So the first message will be displayed. Power. So we have different variable. Click OK. Look at over here. It is showing all the variable. Now is the time we want to display the first message. Okay, power on message. So how to display the first message? Let's create program to display the message. So let's create the program display message. So click the flowchart file, right click the option new sheet. Okay, this is the new sheet. Rename the sheet, rename sheet, and give a name display message. So we have created a new sheet by the name display message. On this sheet, we write the program or flowchart for display any message. Okay, so let's do it. So to write the flowchart, we will pick up the option event block. Drag and drop the event block. Let me just enlarge it. So give a name of the event display message. Okay, click OK. So first clear the display. So find the LCD, look at over here, click the arrow, and it has different function already given for you. So first clear the display. Drag and drop the clear display function. It will clear the display. Whatever was before the display, that will be cleared. Then we will set that text color, set text color. Set text color. So you can set the text color. Already default is white. You can keep it as it is. Then set text size. Okay, set text size. Drag and drop. Text size is the default is 1, but you can enlarge it. If you make 1.5 or 2, your font size will be larger. Okay. Then pick up the option set cursor. At what location on the display the message will get displayed? Okay. Set cursor. So drag and drop set cursor function. Set cursor. So at what location you want to display? Let's say x coordinate is 5 or 10, whatever it is you like. That means on x coordinate 5, and let's say y coordinate 5. You can change it, okay, depending on your need. So at 5 at this location, your message will start or get displayed. Okay. After setting the cursor position, you need to pick up the function called print. So it's a print function. What is it is going to print? It is going to print the message. So this message variable you need to pick up. Look at over here, argument. Click over here and pick up the variable message, because this message variable will hold different messages, okay, depending on the situation. So whatever is the content of the message variable, that will get displayed. Okay, so this is a message variable. Finally, you pick up the function called display to display the message. Okay, display. So this display function will display the message. So this is the display flowchart to display any message that we put in the variable message. So we'll call this function display message wherever we want to display a message. So go to the main menu, and this is the setup. The setup will display the message. First, power on. So how to display the message power on? We have defined the message power on. So we'll call the function. To call the function, we'll pick up this subroutine call block. Drag and drop the subroutine call block. Double click. Choose the function display message. Okay. So the message has the value power on. So this power on message will get displayed. So after we'll display this message for 2 seconds. So give a delay. For let's say 2 seconds, the message will get displayed. For 2 seconds, the message will get displayed. Give the value 2 and the unit is second. Okay. Click OK. So the 2 seconds this message will get displayed. Then we will display another message. To display another message, we need to set up the variable message. So how to set the value of the variable message? Pick the assignment block, drag and drop, and choose the argument message and write down your message over here with double quotation mark. Okay, so you can give the any message. Let's say welcome on board. Okay, welcome on board. And any message that you like, you want to display welcome message, you can display. Okay, after defining the message, you click OK. Then again you call the display message function. So it is a subroutine call. Display the message. I think we have put the wrong block. So pick up subroutine call. Okay, this is the subroutine call, and pick up the subroutine display message. Okay, so the welcome message will get displayed. So this is the initial setup. We have initialized defined event variable depending on our functionality, and we have displayed the welcome message. At this point, I think it's time to save your project, save the project. Okay, now is the time we want to write function for define operation. Okay, first function we are going to write is the forward function. Okay, so right click, flowchart file, click new sheet, and give a name to the new sheet. Rename the sheet, give a name forward. So this is the area that we can write the function forward operation. So drag and drop this event block and give a name to the event forward. Let me enlarge it a little bit. So this is the forward event. So first thing you need to do, set up different state variable. Okay. So to set up different state variable, click drag and drop the assignment block. Okay. So when you do the forward movement, certainly you are not doing the reverse movement. Okay. So reverse movement state is the reverse movement state is 0 at the time. Your brake, certainly you are not using the brake as when you are moving the forward. Brake state is 0, and rotation speed certainly let's set the rotation speed. Rotation speed is equal to speed. This speed variable, as you know, that you set up through the PWM path switch modulation control speed control program that you have done in your lab number 6. Okay, so we use the separate circuit or separate root sheet, okay, to put that speed control circuit, and that circuit will set the value of the speed variable depending on the press of the accelerometer. Okay, if you press the accelerometer more, it will have high value in the range 0 to 255. If you release the accelerometer, it will go down to 0. Okay, so this speed variable will be set by the accelerometer and to the circuit of PWM circuit. Okay, that we have done in lab number 6. So rotation speed is the equal to speed, and what is the other things? Forward movement state. Forward movement state is 1 because we are moving forward. Okay. So that's all I think can do because we don't have more function in the at this point. So after setting the variable, different variable, state variable, okay, we can run the motor. So how to run the motor? Look at the left side of the motor operation, motor 1, run. Okay, with the run function, we are running motor forward direction. And at what speed? Rotation speed. Okay, rotation speed is the value that's set by the accelerometer. Okay, through the PWM circuit. So this is the value of the forward move speed. Okay. And also run the second motor. Set the speed, rotation speed, and then display message. Okay, that car is moving forward. Okay, so how to display the message? You just set the message first. So click the assignment block, define the message variable. This is variable. So moving forward. So you can show the at what value it is moving forward. Okay, so moving forward. So first, what you need to do? You need to change, if you want to display speed, you need to change the value of the speed from integer to string. So the variable speed, the rotation speed, okay, as the value. So you need to convert this integer value to string. So use the function term to string. To string. Okay. This to string function will convert the integer value to string value variable so that the speed of the car can be displayed on the display. Okay, so we are converting integer to string. The rotation speed, close the bracket, and give the message at that speed. Okay, so class display message speed. Give one space speed. And display some information at the beginning. Moving forward at this speed. Okay, so just with a double quote, like moving forward. Moving forward at okay. So it will display the message moving forward at this speed. Okay, so that's the message will be displayed on the display. Click the OK. So after displaying the message of forward movement, call the function subroutine to display the message. Display message subroutine. So message will get displayed. So what we have done, we have written the forward function. First, we have set up the different state variable, and then we are moving the motor forward direction at the speed you set up by your accelerometer. And behind the accelerometer, we have the PWM circuit, right? That we have done in lab number 6. So this is the forward function. Now write the function for brake. This is very important how to break the car, okay? Otherwise, no use of the car. So let's write the function for break. Second, click right click the flowchart file, new sheet, give a name of the new sheet, rename the sheet, and give the name break. So we have now a new sheet to write the break function. Again, when you do the break, again, the first thing to write the function, drag and drop the event block, give a name to the event block, break. First thing, set up the parameter. Event parameter is the assignment block. So when you are breaking, certainly you are not moving forward. So forward move state is 0 at the time. Certainly you are not moving reverse. So reverse move state is 0 at the time. And your break state certainly 1 because you are doing the breaking. Okay. So we have defined the state variable. Click OK. Then you need to break the car. So how to break the car? Look at over here. This is our car control circuit. And if you look at over here, there are two pins, pin number 9 and pin number 8. Pin number 9, IO9, you see, break A. So it will break the motor A. So this is the break pin. Okay, if you make this pin high, the brake action will take place. So it is electronic brake system. Okay, the brake action will take place to the motor. So pin number 9 for motor A, brake A, and pin number 8 for motor B. So we need to give a high value to pin number 9 and a high value to pin number 8 to break the motor. Okay, so how to do it? Go to the visual designer. Let me enlarge it a little bit so that you can see. Okay, so how to give a high value? Look at over here. This is the CPU. CPU has some built-in function to change the value of different pin. Okay, so click the arrow. These are the built-in function for the CPU. This is the CPU function. Okay, and we'll pick up the function digital write. So that you can write the high value to pin number 8 and 9. So pin number 9, motor A. So this pin number 9. And what is the value? We are going to write true value, that is high value, true. Okay, so this will break the first motor. Same way, again another digital write function you can pick up to break the second motor. Pin number 8. Just for the second motor and pick up the value true. Okay, so break operation will take place. Then we'll display the message break on. So again define the message. So assignment block and define the message variable break on. Okay. Now to display the message, we'll call the function subfunction call for message display. Okay. So let's see how it works now. Okay, we have defined two functions, forward and break, and let's see whether they are working properly or not. Okay, we need to test our circuit. So let's save it. And let's see what problem we find. We need to fix it. Okay. So at this till now, what we have done, we have defined the forward function, we have defined the break function, and we have defined the main function, and we need to call this function from our loop. Okay, the loop will test this loop. This loop will test whether you have pressed the button or not. Okay, so this loop will continue forever. The code you write inside the loop, it will continue forever as long as the microcontroller has the power. So first, let's define the forward function. Okay, check the button. Okay, at this in this loop, we'll check different button. Okay, this is the forward button. So let's check the forward button whether it has been pressed or not. So how to check it? Drag and drop the button. This is the forward button. Drag and drop. Okay. So it has two options, whether the button is pressed or not. If the button is pressed, yes, otherwise no. So we will just swap yes and no for our convenience, writing the flowchart. Right click the forward compare option and swap yes no. Forward block and swap yes no. If you click the swap yes no, then yes will go on the right side, no will come other side. Okay. So if you press the forward button, we call the function forward. Okay. So how to call the function forward? It is function called forward. Okay. Otherwise, we will not call this function. Okay. So if you press the button forward, we will call the function forward to move the forward direction at the speed set by the accelerometer, and otherwise we will not move forward. Okay. Now let's see the brake function. If you press the brake button, what will happen? It will brake the car. So drag and drop the brake button. Okay. So if you press the brake button, what it will do? It will brake the car. So again, call the function for brake. On brake function. Okay. And then not brake, one way. Now is the time I think we can test, and let's see what problem we see and how to solve it. Okay. So let's save your work and let's compile our flowchart so that we can test our system. Okay. So we have implemented two functions. One is the forward in our loop, other is the brake. So we'll move the car forward and it will brake and see whether it is doing the job properly or not, and what problem we face and how to solve it. So let's compile our flowchart and let's see what problem we see and how we'll solve our problem. So it is compiling your flowchart, generating the machine code so that you can upload that code to your physical hardware through the upload button over here, and you can run your car in forward direction. Your car has till now has two functions, forward movement and the brake function, so that you can save your life once you can run the car forward. Okay. Compiled successfully. Let's see. Here program property not declared. Two problems we have got over here. Simulation error. Program property is not defined. Real-time simulation failed tested. Let's see how to solve it. Go to the Visual Designer. Click the project option or build option, and then choose project setting. You see this option has been dimmed. Okay. So what happens? Save your work. And for this type of scenario, what I have found, just close the project and reopen your project. Close the project and reopen your project. and go to the again visual designer and go to the build option and select the option project setting and check the option over here all parameters properly set or not. This is the processor. Okay, this is the processor Arduino Mega. Family is the Arduino. Controller is the Arduino Mega. Input file. Okay, Arduino board is the Mega 2516. This is the clock for delays. I think it looks like okay. Programmer is about AVR dot. Okay. Interface is Arduino Mega 2516. Port speed. Okay. Once if you want to upload the code to the real hardware, you need to give the port. Either COM port 1 or COM port 2. Give the port number over here, okay? And resource uploader, okay, hex. Looks like fine. Let's okay, let's compile your program now. We have checked the project setting. Looks like fine. So go for simulation, run the simulation. So it is compiling your flowchart. Hopefully it will run this time. Compile successfully. Now it is simulating. Okay. So let's see what is happening. Go to the choose the design option and go to next root or subsheet. Okay, nothing has been displayed over here. Okay, you see, it is not working. It is not showing any animation or simulation over here. Okay, so what you need to do, stop your simulation and close your project again. Okay, probably this is the bug of the software because it's the older version 8.6. Probably in the new version, or depending on the operating system, I think this problem usually does not happen. Okay, so again, open your project. Run the simulation again. Animating. Let's see. Design window. This time also it is not displaying. Stop the simulation. Okay, again simulate. This time it is working. Look at over here. You see, it is displaying the message power on. Okay. Now you see, look at over here. It is automatically come in the break on position. So this is certainly, if after power on, it is automatically come to break on position. It is certainly a fault. Okay, not working properly. Let's press the move forward button. The car is moving forward. Again, it is automatically coming to the break on position. Okay. So there are some modification of the code you need to do. So let's stop the simulation. Let's go to the visual designer. Let's see what problem is over there and how to solve it. Okay, look at over here. If the button is not pressed, what will happen? It will come to the break. And look at over here. In break, if it's not break, then it will continue. You see, so break function will be called. You see, if there's no break function will be called. So there's a mistake. We do not solve this yes no. So right click, stop yes no. Save it and run the simulation again. See, now look at over here. Power on. First message, it will be this. Then welcome on board. Your car is ready to move forward. Press the forward button. You see, moving forward at 255 speed. You see, this is the message. Okay, you can format this message to display it properly. The car is moving forward. You see, if I just enlarge it, look at here. You see, maximum speed, the car is moving. Plus 459, okay? That's the maximum speed, the car is moving forward direction. Both motor are moving in forward direction. Maximum speed. Okay, now let's say brake the car. Okay, press the brake button and see what happens, whether the brake function is working properly or not. If we press the brake button, the car will gradually stop. Press the brake button. Brake on. You see, brake function has taken place, but it's still moving slowly. Yes. Okay, brake has been done. Okay, brake is on. Okay. Again, move the forward movement. Moving is forward direction at high speed. Then press the brake button. You can, if you press the brake button, keep on pressing, and you also release. I think. Let's see how it works. I just kept the brake button pressing on. Okay, it is taking, it is braking the car, and now I have released the brake button. Okay, so brake function is working for me. One here. Again, let's move the car moving forward, then brake the car. Just one time, I just pressed the brake button, then released. Braking action is taking place. You see, motor cannot stop instantaneously. Sometimes it will need to completely stop. Okay, so now the car has been brake on, and the car has been stopped completely. So it looks like this function is working properly. Okay, moving forward, brake on. Okay, so I think they are working properly. We can go to the next step. Press the simulation stop button so that we can move to the next step. So we have done forward, then brake. Now we will implement the reverse function. Okay, so to implement the reverse function, again same thing. Drag and drop the reverse button. Swap yes no. Then call the reverse function. Call subroutine. Drag and drop the subroutine block and pick up the subroutine for. Okay, we do not write the subroutine for reverse, right? So let's write the subroutine for reverse. Okay, so how to write it? Right click the project file, new sheet, rename your sheet, reverse. Okay, then you have the area to write the reverse function. So drag and drop the event block. Give a name to the event reverse. Okay, and set up the event parameter. This event parameter is very important. Pick up the assignment block. So when you are doing the reverse movement, then certainly you are not moving forward. So forward state is 0. Brake state is 0 because you are moving reverse is not braking. And reverse certainly reverse move state is 1, and the rotation speed At what speed you are doing the reverse, that speed you set up from your accelerometer by the PWM circuitry, right? So that speed variable, the speed variable you have that at what speed you want to reverse, that is set by the accelerometer, okay? So rotation of the speed. So we have initialized different parameter, state variable. Then we run the motor in backward direction. So motor 1, pick up the option, run, okay, and choose the option backward, and speed is the rotation speed. Okay. Another motor, run, block, double click, choose the option backward, and this is the rotation speed. Okay. Then just display message. So define the message by the assembly block. Just define the message same as before for third operation. First we convert the speed, okay, the string. So use the function to string, and you need to convert rotation speed. Okay. Use the plus sign, then double question mark, give a space. You can use that distance speed, and at the beginning you write moving backward. Okay, with double quote, right? Moving reverse. Okay, moving reverse. Reverse at negative 1 space plus. Okay, so it will be moving reverse at the speed. Okay, you can just format it. Okay, you can give more space. Then call the function display. Okay. Okay, so we have defined the reverse function. Save it. Then go to the main sheet. Okay, and all the function over here. Reverse. Okay. And now let's see whether our system working properly or not. Now I can check it. Okay, save it. Okay, now I can compile. Okay, power on. Welcome on board. Okay, let's move forward first. Moving forward at highest speed. Then brake the car. Brake on. Moving reverse. Direction. At the speed is set. Highest speed. Right? Moving reverse at 255 speed. Okay. Now brake the car again. Brake on. So they are working properly. So let's stop the simulation. And finally, what we will do, just want to move right, okay? If it is manual operations, when you press the right button, it will actually prepare your car for right movement. That means it will slow down the speed, okay? So let's do it. Visual Designer and pick up the drag and drop the right movement. Okay, so drag and drop the right. Make sure stop yes no and call the right function. So this right function we need to define now. So again, click project file, right click, add sheet, and rename the sheet as right movement. Move right, okay? Correct, right, move right. So this is the space how you can write the function for move right. So again, drag and drop the event block. Set up the parameter, assignment block. So when you're doing the right movement, certainly this is a high value, and right move is 1. Then forward move state. Forward move state is 0. Reverse move state is 0. Break equal to 0. Break equal to 0. Okay. And automation is the variable. Display message that slowing down. Okay. So I can assign block. So display message that car is slowing down. Message. So write the message with double quotation mark. Then call the function to display this slowing down message. So how to slow down? You see, the brake function actually will do automatically over here because for slowing down, first with the brake function, then the car will get slow down. Okay. So we'll slow down. First we'll do breakdown. Okay. So we'll pick up the function from C2 function digital, right? As you have done in the break function, digital, right? So pin number 8 and pin number 9, right? So pin number 8 and 9, 8 till breakdown, and pin number also 9. And the digital write function, pin number 9. So it will break down your car. Now I think what we need to do, we'll wait for braking, okay? So that it will give a delay of over here. Let's say give a delay of 5 or 4 seconds. Give a delay. So how to give the delay function? Set the delay block and give a delay of, let's say, 4-second delay. Okay, then you release the break. Okay, so how to release the break? Just we'll continue this flow chart. So it is taking more space. We'll break the flow chart over here. Split. If your flow chart is bigger, then you can split and continue. So after doing the break, we'll remove the break. Okay, after 4 seconds, the car is already slowed down. We are going to remove the break. Okay. So how to remove the break? Again, digital right. In number 8 and 9. 8. Pause. Pause. Okay. And number 9. Also. Okay, so we have just automatically from the program remove the break and we set the speed. Okay, we set the speed. Okay, at a slow speed so that when you press the forward button, it will not move at high speed that was set before. Okay, so we'll give a slow speed. So put the variable assignment block. So manually change the value of this speed. Speed variable, US flow is let's say 60, or depending on your situation, you can change the value. Okay, so we give a slow speed, then we give a message that ready to turn. So when you press the forward button, the car will move at slow speed. Okay, and you just steer your car in the right direction. So you have automatically slowed down the speed after braking. We have given a slow speed, and we are displaying a message that ready to turn. Okay, so again assignment block for the message. So the message on the display that ready to turn. Double quote. Okay, ready to turn. Okay, and then display the message by calling the display message function. So we have written the function for our guide movement. First, we have set up the event parameter. Then we are display message slowing down. Then we are braking the car automatically. After 4-second delay, we are releasing the brake, and we set the speed 60. Okay, we set the speed 60. And in that time, in 4 seconds, you can change depending on your scenario. Okay, it is depending on your scenario, you can adjust the timing. Then you see the slow speed, and this is the message return. So when you see the message return, you just press the forward button and steer your car to the right direction. Okay, so it's just prepare your car for right movement. Okay, and left movement is similar fashion. Okay, similar technique. So let's test. Let me first complete the flowchart. Go to the main flowchart and just call the function right move right. Okay, I think we did not change the name of the function. Okay, so change the name of the function, move right. So unless you change the name, you don't know what function it is. For a bigger project, it is very important. Okay, to have move right. Okay, to have proper name for different function, so that you can easily understand what function it is. So move right. okay, and certainly I think after this I come over here. Save your project. Now it's the time for testing, okay. So again, run the simulation. Flowchart complete. Block point at the highlighted group for further information. Okay, probably some mistake we have done. What mistake we have done? Following, okay. Display message. Yes, okay, look at over here. There is no name. Okay, I think that's the mistake. Was done not name was not given properly. So move, or just give the right move. Okay, just right, right. Okay, so let's go to the main function. You don't have any move right. The right. Okay, so you have the right. Okay. Okay, now save your project and compile again. Now compile successfully. Nothing happening. So close the simulation, close your project, and you open your project again. So this is the software issue, and on I think later version, I think I may not get this type of issue. Okay, or it depends on the operating system. I am using the operating system Windows 11. That is new operating system, and the software is not the latest version. It is 8.6. The latest version is the 8.12. I think is the latest version. Hopefully it will run this time, because this is not actually our problem, our fault. It's the fault of the software. Okay. Sometimes it makes this type of problem. Design, go to the next, still not working properly. So stop the simulation. Okay, run the simulation again. Now it is working properly, but doing some error. Okay, stop the simulation. Okay, doing some error. So how to solve these things? Actually, I think we need to take care of different state variable. Okay, probably it is making mistake on some state variable. So how to solve it? First, let's check the break function. Okay, actually I simulated the system in another computer, and I have found similar error. Okay, in that case, by taking care of the state variable, the problem was solved. First, let's check the break function. Okay, so this is the break routine. Now, how the break works? Someone can press break just momentarily and release the brake. Someone can press and hold the brake button. Okay, so to take care of the time, amount of time you press the brake button, okay, there are some more, I think, consideration we need to make. So what I have done actually, On the main function, I have tested the event variable. Okay, and let's do it over here. This is the condition. On this condition, we test two variables. Okay, forward move state and right move state, because let's say let's check those two variables. The forward move state is 0. Forward move state equal to 0 at the time when you are doing breaking. This is the AND operation, and within bracket reverse move state equal to 0. Okay, so in that case, if this is 0, then what we can do, just swap yes no, we can release the motor, because someone pressed the break button for some momentarily, someone pressed for more time. Okay, so what we need to do, if this is at 0, okay, then I think if the brake is not pressed and if this twisters at 0, it is not moving forward, it's not moving reverse, what we can do, we can release the motor. Okay, you can call the function called release. Look over here for the motor. This is a trial and error. Okay, this is that type of program that do trial and error. Okay, so we release the motor. Release the motor 1. Release motor 2. Release is something like that. It will let your motor in free run. Okay, there's no brake. So already brake has been done, but it's slowing down. But it will no forward or backward movement. Just free run. Okay, the car will move freely. Free run. Okay, release. Okay. So brake will let the car move free run. And probably also, okay, we need to take account of another situation. Let's see whether it does exist or not. And also what we have done, okay, forward. Another condition I think we have introduced over here to take care of the situation. The condition variable is again, and what condition we test? Forward move state is 0, reverse move state so forward move state equal to 0. Reverse move state equal to 1. This is the programming issue. This is the trial and error depending on the scenario. Okay. To 0. And right. Okay. copy. Let's check it again. Open a notepad, okay, because it is not showing properly. Error operator expected in condition. Okay. Double click. No, double click is not showing. I think something is missing over at the end. Okay, it's not showing properly. Let's just copy it. Let's go to another notepad or let's see. Okay, cancel. Okay, just let me check. Okay, the condition. Forward move statistical 0, reverse move statistical 0, break 0, and right move statistical 1. Looks like okay, right? Forward statistical 0. And reverse. This is the condition. Okay, it is true or false. It looks like it is okay. Right move equal to 1. Error operator expected in condition. Looks like it is showing the right move. Let's do it again. Forward move state 0 and reverse move state equal to 0 and break equal to 0. I think it is doing some mistake because it's supposed to show. This is the fault of the software actually. You see. Cancel. Let me save the project and open it again. Sometimes it solves the problem. Okay. So close the project. Open it again. So we are defining this condition variable. Let me write it again. Okay. Forward move state equal to 0. Reverse move state equal to 0. Break equal to 0. Equal to 1. I think I am giving the right value, but sometimes the software makes this problem. Okay, actually it is a software problem. See, it is showing the right, but since it is not displaying the full thing, that means it is taking up to this portion. okay, and then operator expected in condition. So it is, I think, doing that two equal. Okay, so what I can do, I can write over here, copy and paste from there. Usually one equal works because actually I simulated this one before I doing this one, and it worked before. I don't know why it's not working at this time. Double equal because it equals out, that means when they're um, I think boolean, I think then we use double equal. We are using in the integer, right? Let's see. Okay, I don't know what it worked before and it is not working right now. Okay, and I don't know what is the reason. Most likely it is a software problem. Okay, so this is same problem, but because after the display is not taken, you see, the cursor should move after the display, but cursor is not moving. So I think it is the software issue. So let's delete this decision block. Just delete the block, okay? Yeah, delete block is corrupted. So again, drag and drop again, and let's go up there and make a because okay, let's just copy and paste. It is strange, I think. Cancel. I think delete this block, save it, close it, and open the file. Because it worked before. Okay, that another computer actually I have done, and it is working over there. And because mainly it is a software issue. Otherwise, it is working in another computer. Forward move the state equal to 0. Zero. Break equal to 0. Into okay, it is tick mark. That means this is okay. Offer expected information. This is the condition, okay, and the condition will be true if all are true. For the time, just let's do it again. Let's see how to take over up to this one. Against them, because it's not our problem. Okay, it is a software issue. Okay, doing the same issue. Operator expected in condition. Is the right? Okay? And it can be true or false. Okay, overall it can be true or false. So just delete this one at this point, save it, and let's see how it is working. Okay. So it looks like software is making some problem, not working properly at this time. Okay, what I can do, same thing that is working in another computer. Let me take that file and simulate that file over here. Let's close the software. You see the already it is making problem. Okay, let me just run the software again. Run as administrator. So that's the project that I have done before this demonstration. And I have found it was working properly. Okay, and this type of mistake I think it did not show. This is the second page. The visual designer. Look at over here. Look at the condition. See that same condition I have written over here. It is not doing any error. Okay. I don't know why it is doing the error, but it's working properly. But same thing. Okay. Same thing that I have done. Same thing over here. Okay. So let me just run the simulation. Power on. Okay, welcome on board. Now move forward. Okay. The car is moving forward. Brake the car. Brake on. Okay. Reverse. Right from there. Slowing down. Ready to turn. Okay. Now it is working properly. Let me just stop it. Let me just fix one thing. In the right movement, if I reverse it, this value should be the speed. Okay. I think instead of rotation speed, you change the speed, because speed is the main parameter. Okay, that we use for movement. So when you press the forward button after hitting prepared for right movement, it will move at slow speed. So save it, compile it again. Okay, power on. Come on, go. Move forward. That the speed, highest speed that you have set up by the accelerometer. Brake the car. Brake on. It's working. Reverse. Now let's right direction and to go. Slowing down. Ready to turn. Now, if you press the forward button, you got over here. If you run forward at slow speed, so that you can make let's say stop turn. Okay, moving forward at 60 speed. So speed is already slow, so that you can safely make the right turn. Similar way, you can implement the left turn. Okay. So this time now it is working properly. Let me stop the simulation. Now, do you have any question at this point?
Thanks. Click on this bed.
Do you have any question at this point? So this is the flowchart, main flowchart. Several conditions have used, okay, depending on the scenario. Because as I have told that this condition, even condition variable, are very important, okay, to test for proper action of the curve. Okay? At every step, for every movement, every decision, you must check different event variable. Okay, otherwise, you do mistake. This is the model like our sample, okay, our basic code I have written. Lots of modification, improvement need to be done with this code to bring the car in the real world. Okay? But this is the guideline, and it shows how to break a bigger job into a smaller part. Look at over here. You see, by the design, go to the previous. Okay, this is the main design window with the Arduino Mega board. Then another sheet we have next group or subsheet. We have design or some circuit. Now what I suggest, get another sheet design, new root sheet. Over here, you design your PWM circuit that we have done in lab number 6. Okay, and this PWM share, this lab number 6, that PWM circuit will set the variable speed, so that depending on your accelerometer, how you place the accelerometer or the potentiometer. Actually, we have this potentiometer that will be converted to accelerometer. Okay, that how you move the potentiometer to accelerometer, it will set the speed, and that speed will take effect whatever movement you do. So the circuit of speed PWM speed control will come over here. Okay, and as your circuit become more complex and complex, more substrate you can create to extend your circuit. Okay, it is limitless. So it is a very good environment to design a complex system like car. Okay, car is a complex system, and this is only the basic circuit. There's many other circuits. There's a air conditioning system, window control system, wipers control system. Okay, exhaust system. Okay, many extra small components they have. And let's say power mirror. Okay, lots of things comes from here. So for every component, we can create a separate circuit on different sheet, and you can combine. And also, not only one microcontroller, if needed, you can combine different microcontrollers. Okay, this is one main microcontroller. You can use a backup microcontroller. Okay, in case main microcontroller fails, the backup microcontroller will take over. Okay, so and this is very important to use the event variable so that you can keep track of what is happening, and so that you can take the right decision. So this is just only the beginning, and the journey will continue. Who knows, someone of you maybe will be interested to continue your work designing the car. So first you design the basic car, a basic electrical car system, okay, with manual steering, conventional steering. Then after designing your basic car, market it, earn some profit. Then you go for auto steering or auto operation. Okay, let's say auto parking, auto right movement. Depending on the scenario, we can do sharp right turn, normal right turn, wide angle right turn. Okay, all the things Painter program can set in your program. Okay, very easily if you manipulate different modules separately. So that's the next step. Okay, after you get success in your primary card design, scale the card, get some profit, then move to the next step, do some automation. After that, go for the transformer design. Okay, has you seen the movie Transformer? It is a robot car. Okay, robot at the same time with the press of button, it can become a car become the robot become the car. Okay, and who knows? One day you have a battalion of transformer. Okay, to rule the world. So you can make your dream come true. But only thing it needs more effort and fine tune your program, more effort. That means you need to do invest more, design the prototype, test your prototype in the real world. Okay. Also, with it, you need to consider the battery system. Okay. Many other system comes in consideration when you implement the system in the real world. Also, gradually you can add the image processing. That means your car will have some vision and it will analyze the road scenario and can take the decision by itself. Okay, so those things are usually not completely new. Okay, already visual systems are available. Um, Also, you can design. Okay, if you more invest in time, you can easily go for more artificial intelligence car design. Okay, and those things are coming in future. Okay, so in future, I think. You want to plan for the future, not only for the present. Your design should meet the future plan. Okay, and this is the way. I think this is your breakdown your different function and different blocks. In future, you can easily modify the block. Okay, if you want to improve the block, just modify over here. If you want to modify over here. Okay, just modify different part. Okay, and easily to modify because your program has been broken down. It is called divide and conquer approach. We divide the bigger problem into smaller parts and solve smaller parts separately. And finally, they are combined, and you have got the complete car system. Okay, so the journey starts here, and it continues with your effort and with your interest. So our time is, I think, let's stop over here. What I suggest for your project, what you do, you see, you add the lightning system because for your project you need to do some more job. Add the PWM system over here, speed control system over here, and get another root sheet. Okay, and add the lightning system because when you do the right movement, the corresponding light should go on. Okay, when you do the left movement, the corresponding light should go on. When you do the forward movement, the corresponding forward light should go on. Reverse movement, back light should go on. So those lightning system you implement over here. So add those modules. Okay, for your project. So as far as you can go, I am not pressurizing to do a more complex job. Minimum the PWM speed control system that already you know how to do it, and the lightning system. This type of up to this point you need to do for your project. So let me stop over here, and the journey begins over here.